Hello everybody watching akssy to make things easy YouTube channel. Please subscribe to akssy to make things easy YouTube channel so as to get videos in mathematics, physics, IT and technical drawing subjects. When you have questions, suggestions or comments, please use the following addresses to reach us: fakadalagasa@gmail.com, 0941 58 75 75, or directly write your questions or comments under the comment section of newly uploaded videos. If the thing you write is a question, we will solve for your question and then we'll upload the answer for your questions. Or if you write comments, we will shape ourselves in accordance to your preference. So please subscribe to this channel and click on the bell-shaped icon of the YouTube channel so that you will get new videos, and also notification message will reach you when new videos are uploaded. Today I'm going to solve a problem on physics grade 9 students textbook, which is review problem on page 85. Let me directly proceed to the problem. The second problem of this review problem says that three forces are acting on an object in equilibrium, as shown in the figure 3.95. Either using a scale diagram or mathematically determine the magnitude and direction of the force X. Here is a diagram. Here we are given a horizontal force of 10 Newton, vertical force of 50 Newton, and a force that intends to balance this horizontal force and vertical forces. So let's proceed to the solution. Even though we are given option to use either a scale diagram method or mathematical method, I want to solve this problem in both methods so as to show you how you can get the answer using either of the two methods. So I will use both of the methods, but for now let me start by method 1, which is scale diagram. In scale diagram we have to use a scale. Since we are not given a specific scale, we can assume our own scale. So by this I assume 1 centimeter to 10 Newton force. So my scale from now onwards is 1 centimeter represent 10 Newton force. So with this scale, the 50 Newton force is represented by 5 centimeter. The materials required to do this problem with this method are paper, ruler, protractor, and pencil or pen. Using scale diagram, let us draw the vectors which are scaled by 5 centimeter, 1 centimeter, and x, vector x, 1 centimeter. The vertical 50 Newton is represented by 5 centimeter. Now, since this force is upward and this is just in the rightward, the two opposing forces that balances out these forces are just in the opposite direction to their respective values. For example, this has to be in the opposite direction to the horizontal because it has to balance out the value of 10 Newton, which is represented here by 1 centimeter. So 1 centimeter has to be drawn in the left hand side of, or in the left x-axis, in the negative x-axis direction. This is the 5 centimeter which counterbalance this 5 centimeter. Now I fully completed a parallelogram with the given scale. So this is 1 centimeter, 5 centimeter, and 1 centimeter. Now what I left is I have to draw a diagonal that joins the opposite vertices of this parallelogram. This is x as given in our problem, which can be represented by r. Let's denote this angle by angle theta. Then by direct measurement, we have got r is equals to 5.1 centimeter and theta is equals to 78.69 degree. Okay, now these are results of the direct measurement from the parallelogram which we constructed just earlier here. But we didn't fully find the answer for the problem. To get full answer, I have to convert this centimeter unit into the Newton unit by using the scale which I considered as the start of this problem. So by using the scale which we used at the start of this activity, we have r is equals to 5.1 centimeter times 10 Newton by centimeter, which is equals to 51 Newton. Let us check it. Xx, which is the x component of force x, is given by 51 Newton times negative of cos of 78.69 degree. This negative is because in the third quadrant, both cosine and cosine are negative. Therefore, it takes negative sign here. So we get 51 Newton times this, which implies 10.001982 Newton, which is approximately 10 Newton. So correctly, it balances the force which is given in the positive x direction. So negative 10 Newton plus 10 Newton, which is 0, which is the expected value. Xy is equals to the component of vector x or force x in the y direction is given by 51 Newton times negative sine of 78.6 degree, which implies negative 50.0096 Newton, which is approximately 50 Newton. So our expectation is correct, and we have shown and solved this problem with the method 1, which is the scale diagram or graphical method of vector manipulation. Let's solve this problem using mathematical method, which is method 2. Now let's draw the vectors as given earlier. This was 10 Newton force, and we have also 50 Newton force. This is vector x or force x that balances or cancels out this so that the object remains stable or in equilibrium position. So we have this x along the negative x-axis. Let's draw vertical line to which is opposite of this one. So this is 50 Newton force. This is xx. So by vector resolution method, we can find this as before that we know that if an object is in equilibrium, the summation of all forces acting on an object is zero. This implies that the summation of all forces along the x-axis is equals to zero, and the summation of all forces along the y-axis is equals to zero. Sorry for this subscript. This subscript is y, so please correct it by y. So the summation of all forces along the x-axis is equals to zero, and the summation of all forces along the y-axis is equals to zero. This implies xx, which is force x in the x direction plus 10 Newton is equals to zero, and force x in the y direction plus 50 Newton is equals to zero. This is a given quantities. So by vector resolution, we have x cos theta plus 10 Newton is equals to 0, and x sin theta plus 50 Newton is equals to 0. Now let's separately write these two equations. Let x cos theta is equals 10 Newton be equation 1, and x sin theta plus 50 Newton is equals to be equation 2. So dividing equation 2 with equation 1, we get x sin theta divided by x cos theta is equals to tan x gets cancelled out by x, and what remains is x sin theta divided by cos theta, which is tan theta is equals to minus 50 Newton divided by minus 10 Newton. Therefore, tan theta is equals to 5. This implies that the angle theta can be calculated by taking the inverse of tangent function. So theta is equals to tan inverse of 5, which is equals to 78.69 degree. Now x is equals to resultant vector x is equals to negative 10 divided by negative cos 78.69 degree, which implies 50.989 in Newton, which is approximately 51 Newton. Therefore, for the object to be in equilibrium, the value of x that balances or cancels out the other forces must be 51 Newton at an angle of 78.69 in the west of south direction.